We're caught in a trap. I can't walk out.
Alright, welcome back. Today we're going to be doing the inverse function, using inverse function. Inverse is, another way to think of it in English is the opposite. So I thought, alright, who looks cool with lamb chops? That was Elvis. He made lamb chops, these facial, face here, right here. He made it famous. He was cool, man. He's the king. The opposite of being cool with lamb chops, that's right, your very own Mr. Kelly. Alright, so let's take a look over here. So an inverse relation interchanges the input and output values of the original relation. So we take our x's and we make them our y's. We take our y's and we make them our x's. This means the original domain and range are also interchanged. So here's our original function. 0, 6, 1, 4, 2, 2, 3, 0, 4, 2. Now, we plotted these in blue over here, all right? And now here's our inverse. So I just flipped. Instead of 0, 6, it's 6, 0. Instead of 1, 4, it's 4, 1. 2, 2 is the same because they're the same input and output. 3, 0 becomes 0, 3, and so forth. All right, we just switched them. And you can tell on the graph right here, the graph of an inverse relation is a reflection of the original relation across the line y equals x. We talked about this in geometry last year, right? Reflection. So if you take a look right here, we have this reflection. This point, right, is 1.5 units, then 1.5 units reflected there. There's a mirror of every point in that line y equals x. And that's going to be true for all inverse relations. Okay, now let's get to the fun stuff. So, the first thing you need to understand is how can we find an inverse? To find an inverse, we're going to do exactly what we talked about. We're going to take our x's and switch them with our y's. So over here I have a y, so I'm going to change it to x. And I have my x, so I'm going to change it to y. Now to find this, we always like y by itself, so now we're just going to solve this for y. So I'm going to have to do the opposite. That's adding 7 to both sides. So now I have x plus 7 equals 2y, and then get y by itself, I have to divide by 2. So y equals x plus 7 over 2. So this is the inverse of that. Alright, let's try this one. It's a little bit more tricky. I'm going to check x equals y squared minus 5. And remember, if you're not sure how to solve these, when you solve equations, you're always working backwards. So we have exponents, we have subtraction, we're working backwards. So we have to undo subtraction first. I'm going to add 5 to both sides. So now I have x plus 5 equals y squared. Now the opposite of squaring is taking the square root. And remember, this is an even exponent. When I take an even exponent, I have to do the plus or minus the square root of x plus 5 equals y. So there we have our inverse function right there. Now you can kind of see this inverse is actually made up of two parts. Alright, so let's try this one. Remember, h of x is just y. So I'm going to put y, I'm going to change that to my x because I have to flip it. So x equals 3 halves y to the 4th. Now I'm going to multiply by the reciprocal, 2/3, because it's easier than doing all the division. And in the end, we're just going to divide by multiplying by the reciprocal anyway. So now we have y to the 4th. We're going to have to do the opposite of that, which is taking the 4th root. And again, remember, anytime you have an even, it's going to be plus or minus. So, plus or minus the 4th root of 2/3 x equals y is now our inverse function to that one. Alright, let's try this last one. This one looks pretty long, doesn't it? So, x equals 2y to the 3rd minus 5 over 9. So, let's check this out. Let's do a little order of operations here. We have divide by 9. This is all being grouped, isn't it? So inside that grouping, we're going to have some stuff. But first of all, you have to understand this. This is divide by 9, so I have to multiply by 9 first. So now I have 9x equals 2y to the 3rd minus 5. Now I have multiply, I have subtract, and I have an exponent. So I have to add 5 to both sides. So now I have 9x plus 5 equals 2y to the 3rd divide by 2, because the opposite of multiply by 2 is divide by 2. 9x plus 5 over 2. And last but not least, I'm going to take the cube root. The cube root. So, what do we have? We have the cube root of 9x plus 5 over 2 equals y. That is our inverse. Remember, when you take the cube root of something or an odd numbered root, you're not going to necessarily, you don't need to do the plus or minus because the cube root gets rid of that. So, pulling off the hipster look, well, Johnny Depp's pulling it off pretty well here. Who's not pulling it off? The inverse of that? Ooh, Mr. Bean, nice. Nice. What is up with you Ramstein guys and your bow ties? I'm telling you, you guys kill me with that stuff. Alright, let's take a look. Inverse functions. Inverse functions are when both the original relation and the inverse relations are functions. So not every time you take it out is it actually going to be a function. Alright? Remember, a function means for every input there is exactly one output. And we do that vertical line test. Remember, the vertical line test, if it touches twice, it's not a function. So for example, when we did this one earlier, we had a y, I'll even show you. This one right here looked like this, and its inverse is going to actually, it was two parts, right? It's going to look like that, and it's going to look like that. Well, that inverse is actually not a function. And since it's not a function, it's not going to be, they're not going to be an inverse function. So let's take a look. How will we know? Functions f and g are inverses of each other, provided that f of g of x, so when you put the function g of x into f, the only thing that comes out is x. And when you do it the backwards, g of f of x, when you put f into g, x is the only thing that comes out. So inverse functions of f of x is written as f inverse x and is read as f inverse. It is not a negative exponent. In other words, you're not going to take this and put it over 1. It's not following the exponent rules because it's not a negative exponent. It's shorthand for f inverse. So let's take a look at this first one. It says determine if 3x minus 5 and f inverse of x, 1/3 x minus 5/3 are inverses. So let's try it. Let's try f of g of x first. So here we go. Plug it in. So wherever I see my x, I'm going to put in my inverse. So that's 1/3 x minus 5/3. 3 times 1/3, so that's just going to be x. Well, that's a good start, right? 3 times 5/3 is going to be 5, so minus 5. But then we get here, we have x minus 10. Well, that is not just x. And remember, the rule says it has to equal just x to be inverse function. So this is not, all right, not inverse functions. Let's try this one at the bottom. Ooh, it looks real fun. So let's try f of g of x. So wherever I see my x, I'm going to put my function g in there. So I'm going to put in the square root of x plus 1 over 3. So here we go. Well, squaring a square root, it cancels each other out, doesn't it? So now I have x plus 1 over 3 minus 1. And the 3's cancel out, so now I have x plus 1 minus 1. And plus 1, well, that leaves us with just x. So f of g of x does indeed come out to x. So far it's looking really good. Let's try g of f of x, though. Never can be too safe. Let's try them both. So now I'm going to plug it into this function. Whatever, I'm going to put my f in there. So my f function again is 3x squared minus 1. Now this looks much harder to solve than it actually is. Negative 1 plus 1, will those cancel? So now we have 3x squared over 3. 3 over 3 gives us x squared. Right? And the square root of x squared is x. All right? So these are, in fact, functions. Now, there is one little trick about this one. All right? This is only for a certain domain. This is only for, range, for when y is greater than 0. because it will only go up here like this. All right, if I had completed y, all possible y's, it would look like that, and it would not be a function. All right, so that is a caveat to that problem, but sometimes that happens. All right, so Ryan Gosling is able to pull off a mustache, and the opposite of that, the inverse, Mr. Brust, not looking so great with that mustache. But worse are these female glasses he's wearing. Looks like he has to borrow his glasses from his wife. Brust, you make enough money to go get your own glasses. All right, so let's take a look at this. We're going to be able to use this, see if we can find inverse functions, if they are going to be functions. Another way, graphically, all right? So remember we had the vertical line test to see if relations are functions. So we could graph, so here's f of x, and you can see this is a function because it passes the vertical line test. And then we could solve it, and we could have this is our inverse, and now we could, we can see here, that hits twice, that's definitely not a function. All right, so this is not inverse functions. Over here, g of x equals x to the third, so we have this function, and oh, yep, that looks like a function to me. And now look at this inverse. That is also going to be a function. Now, wouldn't it be nice? Wouldn't it just be fantastic if we didn't have to look at the graph of the inverse? If I could look at just the graph of my function. And in fact, ladies and gentlemen, there's a way. So it's called the horizontal line test. The horizontal line test means the inverse of a function f is also a function if and only if no horizontal line intersects the graph of f more than once. So you just take your original function, and instead of doing just a vertical line test, you're going to do a horizontal line test. So over here, I come over here, I have a horizontal line, and you can clearly tell it hits twice, therefore its inverse is not going to be a function. Whereas I come over here, this clearly only hits once, which means it will indeed be a function. Sketch the graph of the function y equals 2x minus 5 to determine if the inverse function is, or the inverse is also a function. So now, when I say sketch this, what I want you to do is go into y equals, plug this in your calculator, and get a graph. All right, so what I've done is I've done that already. Now, some of you aren't really good at the Windows stuff on your graphs and things like that. And what you need to understand is you need a zoom standard most of the time so you can start with a graph. So here's our graph of 2x minus 5. Is the inverse going to be functional? Remember, it needs to pass the horizontal line test. Does this pass the horizontal line test? It definitely passes. So f of negative 1 of x, the inverse, is a function. All right, let's take a look down here. We're going to graph 2x to the fourth minus 5x to the third. See if this is a function. Here is our graph again. I just put this into y equals mx plus b. Ooh, that's fancy, right? Little dip there. That's one we don't see a whole lot. Let's take a look at this. Well, this hits in more than one spot. Therefore, it definitely is not a function. So the inverse of this is not a function. All right. So I want you to pause the video and try these. Great. So let's verify that these are inverses. So I'm going to plug f of g of x. So 1/5 times my g of x minus 1, and g of x is 5x plus 5. So now I have 1/5 times 5 is x, 1/5 times 5 is 1, and 1 minus 1 is x, and that's exactly what we want it to be. All right, so when it comes out of that, so far so good. Now remember, you need to do g of f of x. So we're going to plug our f into my x here. In this case, it's 1/5 x minus 1. 5 times 1/5 is 1x. 5 times negative 1 is negative 5. Plus 5, that gives me x again. So indeed, they are inverses of each other. Come down here, graph the function y equals negative 6x squared x is greater than or equal to 0, then determine if its inverse is a function. So right now, I want you to plug that into your calculator, y equals, and let's see here what we got. So just like that, I have my calculator here. I'm going to put in negative 6x squared. All right, so I'm going to graph that. All right, so now here's the trick. All right, it says only for x is greater than 0. So we're not looking at this part here. I'm only looking at this part. So I'm going to take this line here, and that's my graph, all right? So let's sketch that real quick. So it looks a lot like this. X is greater than 0. It's just that line right there. See, it's not the whole part because they're very specific about the domain. All right? So now, is this a function? Well, does it pass a horizontal line test? Yes. So its inverse is going to be a function for sure. And last but not least, find the inverse. So here we go. Plug in, switch the y becomes x, and x becomes y. Subtract 10 from both sides, so I have x minus 10 equals 4y to the 4th. The opposite of multiply by 4, I'm going to divide by 4, so I have x minus 10 over 4 equals y to the 4th. The opposite of taking something to the 4th power is taking the 4th root. And when I take a 4th and even, I have to do plus or minus. So the inverse is the 4th root of x minus 10 over 4. Do you need the plus or minus? You sure do. All right, so you sure do. All right, so here's another one of my favorite commercials of all time from Saturday Night Live. Almost Pizza. Sounds good. Good luck on the match check, and I will see you on the flip side.
Pizza! I didn't hear the delivery guy pull up.
That's because it's not delivery.
Really?
And it's not exactly pizza either. It's almost pizza.
Come on, that's pizza.
Nope, it's very nearly pizza, but not quite. It's almost pizza. See? Come on, let's eat.
So it's tofu pizza or something like that.
No, you could put tofu on a pizza and still legally call it pizza. But don't call this pizza. It's almost pizza. Pizza that's practically pizza in every way, except for a few key ones. Come on, dig in.
But it's food though, right?
Come on.
Pizza! Nice one, Mom.
Hang on here. What exactly is this, Carol?
It looks like pizza.
It's meant to.
But it's not. If it was pizza, it would just say pizza.
Look, I'll eat some.
Sure smells like pizza.
That was their intention.
Whose?
Just try it, Tom. It's getting cold.
No. If anything, it's getting hotter. Okay, what is this, Carol?
Just eat some.
No!
I'll eat it.
No!
You never said it was pizza.
If it's almost dinner, it's almost time for Almost Pizza. The thing that's much like pizza, roughly speaking. From Pfizer.